we are moving on to 7.3, measures of center. A lot of this will be reviewed for you guys. I think it'll be pretty easy. So actually, let's start with the measures of center. There are 3 different things that kind of tell us where the center of the data is. Can you think of any one of those 3 things, or how many can you think of? So we have the mean or the average, the median, and the mode. Okay, so that typically tells us where the center of the data is. All right. So we want to find the mean, median, and mode for the water temperatures of Grand Isle, Louisiana, and Key West, Florida. Okay, so if we can find the average and the mean, median, and mode, we can kind of compare them and do a little bit more with statistics. So in order to find the median, what do we have to do with all the numbers? We need to put them in order. So for Grand Isle, we're going to have 61, 61, and then 64, 65, 70, 70, 77, 2 77s, 83, 2 83s, and 2 85s actually. Okay, line down. Okay, so when we find mean, median, and mode, the first thing we always do is put them in order. Okay, so we put them all in order. That allows me to find the median because I need the one in the middle. So we kind of go from the outsides and work our way in until we get to the middle. And it turns out, since there's 12, there's an even number. Our middle is right there, so it's between 70 and 77. So what you can do is you can add them together and divide by 2. Or if you already know the number in the middle, you can just write that. So for the median, since we have, since it's in between 2 numbers, we'll take 70 plus 77 over 2, and that gets us 73.5. Okay, and 73.5 would be exactly in between 70 and 77, but if you weren't sure, that's how we figure that out. Okay, mean, remember we just add them all up and divide by the total. Since we're dealing with months here, we'll divide by 12, and I will just give you that number. It's 73.42. And then the mode is which one happens most often. So we actually have a couple modes in here because we have duplicates. So 61, 70, 77, 83, and 85 are all modes. Okay? So hopefully that's a little bit of review for you guys. Let's see if you guys can do the Key West data for Florida on your own. Okay, so we put them in order. Then I can add them all up, divide by 12. The mean is 79.08. After I put them in order, between 78 and 82 is where my median is, so that's going to be 80. That's exactly between 78 and 82. You would also add them together and divide by 2, and you would get 80. There's only 2 modes for this one. 82 is listed twice, and 87 is listed twice. Okay. So, for example 2, and we will be doing a lot with box and whiskers. You're going to have a project with that. So box and whiskers are nice because it gives us a nice visual to kind of compare data. So for example 2, I'll run through the data for Grand Isle. And then you'll do Key West on your own. So in order to make a box and whisker plot, there's 5 things we need, and we call it the 5-number summary. Okay, can you remember any of the 5 things that we need to make a box and whisker plot? So we're going to need the min. We'll need Q1. We'll need the median. We'll need Q3. So median is kind of like Q2. and we will also need the max. Okay, min and max are really easy to pick out. We already ordered them, so 61 and 85 are my min and my max. Another reason we need to order them up top is because if I want to find Q1 and Q3, so Q1 is essentially the median of the first half of the data. Q2 is the median. So we can actually fill that out since we already have that, 73.5. And then Q3 would be the median of the second half of the data. Okay, so we want to split it in two, find the middle of the first half, which would be between 64 and 65, so 64 and a half. And that's middle of first half. Okay, and then Q3, we go back up here, find the middle of the second half, which would just be 83. So 83 middle, or you can write median of second half. Okay. So when we actually do our box and whisker plot, we will put a scale. It goes 60 to 85, 61 to 85, so I'll start with 60 and go up by 5s. So 60, 65, 70, 75, 80, 85. So this scale will always change. Okay, but you always want to put a scale first. Okay, I know sometimes in the past maybe you just drew the box and whiskers and you just kind of labeled everything, but we need it on a scale because I need to see compared to other things. Like we need to use the same scale and compare them. Okay, so we can start with all three. Q1 median and Q3 are going to be the box, so I usually start with those. Q1 is 64 and a half, which would be somewhere here. Okay, so that's Q1. Median is going to be 73 and a half, so that's somewhere here. And then 83 would be somewhere around in here. And that's Q3, and that's going to be our box. Okay, and then the whiskers would be the min and the max. So min is 61, and we usually just draw a dot or a star, whatever you want. And then 85. Draw that whisker out there. Okay, so you can see this data is kind of nice and evenly spread. The size of the box on both sides is kind of the same, and these whiskers don't go out too far. Okay, so what I'd like you to do next is do the same thing, box and whisker plot, but now I want you to use Key West. Okay, so you should be using the same scale we used for the previous example. All right, so our min is 69, Q1 is 73.5, the median is 80, we already had that from before, Q3 is 85.5, and then the max is 87, okay, and then this is kind of what your graph should look like, your box and whisker plot. Okay? So, we want to find some percentiles now. So if you guys take any big tests or anything like that, or if you are interested in going to college, they're going to talk about like percentiles, like you need to finish within like the top 10 percentile or something like that, or if you're in the top 5 percentile of the SATs, you can get into the school, blah, blah, blah. So there's lots of ways we can use these percentiles. Okay, so we'll start. Here is a list of data. So you'll need to order these. So maybe make a note, need to be in order. First. Okay, so these, I already have these in order for you, but on the homework, you'll need to make sure that you put the numbers in order before you can find the 20th and the 65th percentile. Okay, because this is like the lowest, think of them as grades. This would be the highest grade. and we need them in order because at some point, like if I cut it in half, this would be the top 50%, this would be the lowest 50%, so I need to have those numbers in order. Okay, so first we have 20, so we use n for the sample size, and that's going to be 20, so there's 20 numbers. And then if I want to find the 20th percentile, what we do is I take the n and multiply it by 0.20. Okay, so that'll give me 20% of the numbers. So 20% of the numbers is 4. So that means 4 numbers, so these first 4 numbers make up 20% of the data. So what we do is I jump to the next one up, and I say 20% of the data is below 47. Okay, so that's how percentile works. So 20% of the data fell below 47. Okay? So then if I want to find the 65th percentile, we would still take the number, but now I want to find 65% of the data, and that will get me 13. So here's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So from 21 to 82, that's going to be 65% of the data. So we'll bump up to the next one and say 65% of data lies below 87. Okay? So that is how we would do those. Okay, so think about what it's asking. You want 20% of the data. So if there's 20 numbers, that's 4 numbers, make up 20%. So then you hop up to the next one and say 20% is below that one because it includes all 4 of those numbers. Okay, below doesn't include the 47. All right? So I would like you to find the value of the 25th percentile of the Key West data. Okay, so you're gonna have to look on the other page at the Key West data and then find that 25th percentile. Okay? All right, so I just rewrote all the data from the front. So we only have 12 numbers now, so you want 25% of 12. So you take 12 times 0.25, and that gets you 3. So these 3 numbers make up 25% of my data, and 25% of the data is going to be below 75 degrees. Okay? All right, moving on to outliers. So what is your definition of an outlier? Okay, so outliers are numbers that are either way too high or way too low, but like what makes an outlier? There has to be some cutoff, right? Like if it's above this number, it's considered an outlier, or if it's below this number, it's considered an outlier. So we're gonna look at what that cutoff is and figure out regular outliers, and then we'll also figure out extreme outliers. So an outlier is any value that lies more than 1.5 times the inner quartile range which I'll denote as IQR, and I'll go over that, above Q3 and below Q1. Okay, so we have regular outliers and I have extreme outliers. Okay, So what this looks like is, before I give you the formulas, I'll kind of explain it in words. So we have a box and whisker plot. The interquartile range, so if you think of range of data, would be from the highest to the lowest. So if you think of quartile range, it would be the distance between Q1 and Q3, or the length of our box. So the IQR is going to be the length of the box. Okay? And we have this box length. If it is more than 1.5 box lengths out, so if we had a number all the way out here, that's considered an outlier. If it is 3 times the box length, that would be really far away, and then we would have an extreme outlier, okay? So the IQR is the length of the box. If it's 1.5 box lengths above Q3 or below Q1, I could go this direction, it's going to be an outlier. So you see this min right here, that is definitely, it's not even half a box length away, maybe a half a box length away. So that's not considered an outlier. It has to be 1.5 box lengths away. So if we think of the formula, so we have 2 numbers, right? So we have a lower outlier number and we'll have an upper outlier number. So if it's really high, if it's bigger than that bigger number, then it's an outlier, but also if it's smaller than the smallest number, it's considered an outlier. So we kind of have 2 formulas here. So I want Q1, and I'm going to subtract 1.5 box lengths, which is the IQR. Or I'm going to take Q3, and I'm going to add 1.5 box lengths, which is the IQR. Okay, so we can multiply 1.5 times the IQR, subtract it from Q1, but add it to Q3 to get kind of those outer bounds. Extreme outliers is the exact same thing, but we're going to do 3 instead. So Q1 minus 3 times IQR, Q3 plus 3 times IQR. Again, we could take the IQR, multiply by 3, that's the length we have, subtract it to get the smaller number, add it to get the bigger number. If any number lies outside of that range, it's an extreme outlier. Okay, so let's look at this next example. So these are all in order. So again, we want to make sure that all the numbers are in order. And maybe, actually, let me put a little note. The IQR is just going to be Q3 minus Q1. So we're just finding the range of the quartiles there. So make sure you have that down. Okay. So in order to find outliers, I will need Q1, I will need Q3, and I will need the IQR. Okay? These numbers are already in order. So when I find halfway through, it is between here. Okay? So halfway between 14.5, or that, sorry, that is, this is Q2 would be in here. So if I want to find Q1, I would take the first half and find the middle of that one, which would be 14.4. And then I can find Q3 the same way, but I'm going to take the second half of the data. That's 14.9. To find the IQR, I just subtract those. 14.9 minus 14.4 equals 0.5. So we have outliers, and then we have extreme outliers. So what we need to do is, I want Q1, and I'll just write it out. So Q1 minus 1.5 times the IQR, which would get me 14.4 minus 1.5 times 0.5. Okay, so that's 13.65. And then I'll take Q3 plus 1.5 times IQR, which would be 14.9 plus 1.5 times 0.5. Okay, and that's going to get me 15.65. So these are the two numbers. That's my range. So if there are any numbers less than 13.65 or greater than 16.65, those are considered outliers. So I look at the lowest number. 10.2 is less than 13.65. It is more than 1.5 box lengths away, so that is considered an outlier. And on the flip side, 15.65, 16.4 is bigger than 15.65, so that is also an outlier. So 10.2 and 16.4 are both outliers. Okay, so since I have outliers, I need to go ahead and see if either of these are extreme outliers. So I'm going to extend the length of the box to 3. So I am going to use Q1 minus 3 times IQR. And I'm just writing this out so you know where it came from. You don't always have to write this out when you're doing the homework. So this would be, it's the exact same thing, but I'm going to change the 1.5 to a 3. So 14.4 minus 3 times 0.5, which would get me 12.9, and then Q3 plus 3 times 0.5, which is this 14.9 plus 3 times 0.5, and that gets me 16.4. So 16.4 is not bigger than 16.4, so that's not an outlier, but 10.2 is still less than 12.9, so 10.2 is extreme. Okay? Excuse me. So we can kind of figure out, if you don't have any outliers, you do not need to find any extreme outliers, because obviously if there's no outliers, there's not going to be any extreme outliers, so you wouldn't have to do any of this. But if you have an outlier, you need to do the math to find the extreme outliers, if there are any. Okay? Why do we even care about outliers? Okay, this might seem like a lot of work and it's a little bit confusing, but why are those important to us? So outliers are important because they can kind of skew the data. Maybe someone entering all the data in for, like let's say they enter temperatures in and they accidentally switch. You had 82 degrees and they accidentally put 28 degrees when they were typing it in. So that might be an error that we can then get rid of and conclude like, well, that's an outlier. It doesn't really follow the trend of the rest of the data, so we can kind of get rid of it. Okay, so let's try one on your own. I'll give you the numbers, so we'll make a nice easy numbers. 21, 23, 24, 25, 29, 33, and 49. Find any outliers or extreme outliers for that data set. All right, so Q2 is going to be, or 25 is going to be Q2, which is the median. So then Q1 would be 2, 3. Q3 is 33, which makes the IQR 10 when you subtract those two. So the length of the box is 10 here. So 1.5 box lengths would actually be 15. 1 box length is 10.5. So 23 minus 15 would be 8. 33 plus 15 would be 48. So anything outside of that range, which is only 49, is an outlier. So then, and you can kind of predict this when, since 49, if 1.5 box lengths is 48, obviously 3 is going to be much further away than that, so this would be 30. So these are nice whole numbers. So 10 is the length of the box. So if it's more than 30, less than 21, or less than 23, and more than 30 greater than 33, then you would have an extreme outlier, but we don't have any because it would be -7 and 63. And obviously there's nothing smaller than -7 down here, and there's nothing larger than 63 up there. Okay? So please reach out if you guys have any questions, and have an excellent day.